Welcome to this video on observational studies versus experiments. By the end of this video, you should be able to explain the concept of confounding variables and how it limits the ability to make a cause and effect conclusion. You should be able to distinguish between an observational study and an experiment and identify the explanatory and response variables in each type of study. And you should also be able to identify the experimental units and treatments in an experiment. So our story activity for today revolves around an SAT prep course. So last year at EKHS, they offered an after-school SAT prep class that students could volunteer to take. 44 students took the course and then took the SAT. The average SAT score for this group was 1220. The average SAT score for all students who did not take the prep class was 1050. So the first thing we need to do is decide, is this an observational study or an experiment? So one thing I noticed right off is it said the word volunteer. So volunteer, if it's a volunteer sample, you already know there's going to be some bias in there for different reasons. And we'll talk about those in a little while. But they volunteered for the class. Nobody gave them the treatment of a class or said you have to take this class. They volunteered for it. And then they just observed the SAT score afterwards. So because there is no treatment given to the students, this is an observational study. So the reason this is an observational study is what we were saying before. The students were only being observed and they were not placed in the course. There was no assignment to a course or not taking a course. They were going to take the course anyhow, and it was just observed what happened after taking the course. So that makes it an observational study. So we're throwing back a little bit where we're talking about our explanatory and our response variable. So our explanatory variable is what we are predicting from. And so in this case, it's whether or not they took the course. Okay, and then your response variable is what happens based on this explanatory. So in this case, it's going to be your SAT score. All right. Okay. So, do you think you can conclude that taking the prep course will cause a student's SAT score to increase? Why or why not? So, if you think about it, could that prep course say, hey, people took our class and they got an average 1220 versus people who didn't take their class, they got a 1050, and say the reason for that is their course, is what they're asking. And really, you cannot say this. And the reason is there's other things going on, like the students who volunteer might be more highly motivated. So we can't really say it's a cause, because the students who volunteer for the course may be more highly motivated and they may study more. And that would create some of the differences that are seen between the two groups also. So what I want you to do is I want you to pause the video and I want you to come up with some ideas of what are other things that may influence a student's score to be better whether or not they took the prep course. So that we're talking about the kids who take the prep course. What are some other influences that could cause their score to be higher? So pause and jot down 3 or 4 and see, and then we'll talk about it. All right, here's just a few ideas that could be reasons that the scores of the students who took the SAT course are better than the scores of students who didn't take it. They might be trying to raise their score for college, so you have more college-bound people taking the course possibly. So maybe they have a higher GPA, maybe they have more knowledge going into the SAT. One thing that they may not have after-school jobs or activities, and they may have rides home. And really what that is kind of indicating is it's a quieter way of saying maybe a higher socioeconomic group, and I'm going to label that SES, socioeconomic group. And that means they have more free money available to them, and there's a whole host of other influences when you are in a higher socioeconomic group. Not that they're smarter, they just have more advantages that can make their scores go higher than somebody who is not in a high socioeconomic group. They may have taken the SAT before, and so they're very familiar with the SAT and they're wanting to improve their score. So that would influence, usually when you take the SAT, the next time you take it, it's a higher score because you've seen the test format and you're ready to take it the second time. So when you have these kinds of things that may be influencing what you're looking at, these are called confounding variables. So your confounding variables kind of muddy the waters because it makes you question, are the results that you're seeing, like this 1220 SAT score, are they truly because of the thing that they're talking about, or is there some other influence going on? Okay. Another thing, this is an observational study. They only observed the students and recorded what happened. If you want to have there to be a cause, if you want to say that the SAT prep course caused the scores to go higher, you would need an experiment. Okay. So when you have an experiment, we're going to do this as an experiment in just a minute so you can kind of see the difference. You need to assign people a treatment before you can determine if there's a cause or not. So remember our explanatory and response variables, we talked about them previously. Your explanatory helps you make your predictions, and your response is your outcome of your study, whether it's observational or experimental. So in this case, whether or not they took the course, they're saying would help explain the SAT score. Okay, and up here we said this was an observational study. And when you have an observational study, that means that there's no treatment was imposed on the people. So a lot of times will use the abbreviation TX for treatment. So if you use that, if you use any sort of abbreviation, make sure you define it for your reader before, and then you can continue to use it from there on, especially like on the AP exam. Don't just write TX and expect them to know that's treatment. But if you write treatment, TX, then as you move on, you can just keep using TX as treatment, and because you've defined it along the way. All right, so this was an observational study. What we're going to do is we're going to design an experiment so you can kind of see the difference. So for this experiment, I want us to randomly choose, because you should always randomly choose people. And let's say 100 juniors. We're going to use juniors because they're more times than not haven't taken the SAT before, and they're the ones who are taking the SAT more often, are more likely to be available for a prep class because they're preparing to apply for colleges as a senior. So we're going to take 100 juniors to be part of the experiment. All right, so we have these people. What are we going to do with them? Well, we need to put them into the class or not into the class. So how is that going to happen? I can't just decide, hey, you do this and you do that, because that's going to have some sort of bias to it. So we need to randomly assign. And how are we going to randomly assign? We're going to say half will go to the class, and half will not. Okay, so we assigned them to the class. Well, then what? Is that just the end? How will we know if it worked or not? Well, they need to take the SAT. So after the course is over, We need all 100 of them to take the SAT. Okay, so once they've taken it, what's really important is we need to compare their average scores at the end. Because ultimately, that's what we're looking for. What difference does it make for the scores? All right. So in our experiment here, we have our 100 juniors. Those are the people that the experiment is being done on. They are called experimental units. Okay. Since they're humans, a lot of times they'll be called subjects. Experimental units is what is receiving the treatment. Okay, and so the treatment, we think a treatment may be like a medicine or a drug, but it's anything in an experiment that's being given to a group that's being imposed on them. So in this case, we have people who are going to the class and we have people who are not. So these are our treatments because it's what's different between the groups of what's being done. Okay, so what we're going to do is we're going to draw this out. So I'm going to show this more as a pictorial of this paragraph, okay? And you can do this either way on my exam and the AP exam. Both are acceptable. So here is my experimental design. I tell you who's going to be experimented on. I'm going to tell you they're going to be randomly assigned and what the treatments are. And then I tell you, well, after the treatments, what's going to happen? You got to make some comparison of some variety. So pictorially, we have our 100 juniors. Okay. You could just write 100 juniors. I just tend to write little people, and they're always happy people. So I'm going to take these 100 people, and I'm going to randomly assign them. Okay, so you got to make sure you tell them that they're being randomly assigned. And they're going to be assigned where I'm either going to have 50 take the class, and I'm going to have 50 with no class. Okay. You want to keep these approximately equal. I mean, if you have an odd number, there's going to be more in one group, but you don't want a whole lot more in one group than the other group. You want to keep these as equal as you can. So taking the class is one treatment, so I'm going to call that treatment 1. The other one is the second treatment. We have 2 treatments here. Okay. Then after they take the class, we could say they take the SAT. And then we're going to compare scores. So this scaffolding down here is exactly the same as this paragraph. Either works for whichever makes more sense to you. I like to do it this way because it kind of makes me think, I've got my people, what do I need to do to them? I need to randomly assign them to what? And you can have more than 2 groups. It just depends on your experiment. Okay, but there's always got to be at the end some sort of comparison. All right, let's do some summary on the back. All right, so I have 2 things that I'm going to tell you. The first one is this narrower section, and then we'll use the whole rest of the box for the other part of it. So we have our observational studies, and remember, an observational study means that there's no treatment imposed. You only observe and report. Okay, that's compared to your experiments. So with an experiment, there's a treatment imposed, and what's good about experiments is it allows for causation. And that's because you're doing your random assignment into groups, so you're able to tell whether something causes something or not. Okay, so if you're looking to determine if something made something else happen, did the prep course make the SAT score go up? You have to do some sort of experiment. All right. And then here's kind of a summary of all the other pieces that we needed to learn today. I wanted to remind you the explanatory variable is used to predict. There can be more than one explanatory variable, and if there is, we call them factors. And the factors can have different levels, and we'll talk more about that in just a minute. Then we have our response variable, which are our outcomes. And then we have treatment. The treatment is what is being done to the participants. You could have plants that are receiving fertilizer. You can have people who are receiving drugs. You could have people receiving, SAT classes. So it's what is being done to the participants and what are you trying to find the difference of. So we have our experimental units. It's who or what the treatment is being imposed on. And then we have those confounding variables. So they're variables that are not controlled for that affect the results. So when we talk about control, we'll talk about it a little bit more. We get that there's going to be differences that could cause, different variables that can cause a change in our results of our study. So what researchers have to do is they have to make sure they're allowing, doing things to wash that effect out of their research. And so we'll talk more about that, but like in drug trials, you could have people taking no medicine and they follow their progress, and they could have people taking a new medicine and follow their progress. And the assumption is the people without the medicine, they're the control group. They should have the same confounding variables as the people who are taking the drug, so the only difference would really be the drug. Okay, so we'll get more into that. But so with your confounding variable, like you could have A causes B and B causes C and C causes A. Like, I don't know, if you can't just take one of those out. They're all kind of influencing each other. So you're trying to control for that in the group by having like allowing for that along the way and acknowledging that that could be a potential. So pause the video, try the check your understanding, and come back and check your answer. All right, so in checking our answers, this first one was talking about the screen adjustment, screen brightness adjustment on the laptops. And they were assigned, see they were assigned the computers at random and they were adjusted. And so because something was done and they were assigned to it, this is an experiment, there was a treatment imposed, and the treatment was adjusting the screen or not adjusting the screen. All right, and then we have the situation with teenagers eating dinner with their families. So according to this ABC News article, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. This finding was based on a sample survey conducted at Columbia University. So was this an observational study or an experiment? So, and it says justify your answer, so you need more words. So this was observational because the students weren't assigned to eat with their families. They just surveyed people and found out whether they ate with their families or not, and then asked about their grades. So observational. What are the explanatory and response variables? So the explanatory was whether or not they ate with their family 5 times per week, because that's specifically what they're talking about in the article. And the response was their grades. And finally, explain clearly why such a study cannot establish a cause and effect relationship. Suggest a variable that may be confounded with whether families eat dinner together or not. So what else could be influencing going on here? So we cannot say there was cause and effect. Well, one, because it's observational, so you definitely can't do that. But the confounding variable here is they could have something else in common that affects their grades. And we were talking about this on the other side. They could be they're from a higher socioeconomic group and they have the time to eat together 5 times a week because their parents don't work shifts, and maybe they're home at dinner time versus at work at dinner time. Or there's so many different variables. It could be that just in general they have better nutrition because they're eating together 5 times a week, and better nutrition will have effect on your grades because you're not hungry. So there's other things than the actual act of eating with your family that could raise your grades. Okay, there's other confounding variables. Hopefully that was helpful. Let me know if you have any questions.